Bismillahirrahmanirrahim. Conservative field. So we discussed conservative field in previous videos. Now we have a field which is equal to grade of phi. F is equal to grade of phi. So this is conservative field. If a field F can be put in the gradient of phi, where phi is a single valued scalar function with continuous partial derivative. Show that work done in moving a particle from point 1 to point 2 is independent of the path joining the 2 points. So if the field satisfies this condition, then the work done is independent of the path. That is first part. The second part is converse of it. If this integral is independent of the path, then we have to show that the field is equal to grade of phi. So this is the converse of the above. So let's prove it. Okay. So let field is equal to grade of phi. Grade of phi. Work done is equal to, in the field is equal to, from point P1 to P2 is F dot dr. But F is equal to grade phi, so that is grade phi dot dr, and this product is equal to d phi, P1 to P2, that is d phi. So that implies phi from P1 to P2. So the work done is equal to phi f of P2 minus phi 8 P1. So you see, this is the work done. So this required no path. It only required the final position and initial position in the field. So work done is independent of path. Now we have to prove the converse. The work done is independent of the path. The work done is independent of the path. We have to prove that the field is in fact grade of phi. Now look at this statement that the work done is independent of the path. So we can choose any path in the field between 2 points. The work done is same. Moving from point P1 to P2 in the given field, the work will be the same. So that means there exist scalar potential phi which is well defined and which is equal to this work done. As it is independent of the path, so taking any path we will get the same phi. Taking any path for this work we will get the same phi. Now take the differential on both sides. We have d phi is equal to f dr. Okay, so from here we come to the conclusion that d phi is in fact f dot dr. But we know that what is this d phi? This d phi is gradient of phi dr. So this implies that gradient of phi minus f dot dr is equal to 0. So this implies grade of phi minus f is equal to 0, mean that is 0 vector. Regardless of the dr, that implies that f is equal to grade of phi. So if the integral, which is the work done, is independent of the path, then the given field is equal to grade of phi. So let's see this question. If the field is grade of phi, then we have to prove that the work done is independent of the path, followed by the particle between these 2 points. And when the work done is independent of the path, then we have the case that force is equal to the grade of phi. We prove it in this question. So we can write that f is conservative the field is conservative, then work is independent of path. F is conservative, then work done is independent of the path. That is the first statement. In other words, that we can say that if f is conservative, then work done is independent of path. And the converse is, this is one statement, that is this A. The converse is if work done, which is equal to f dr, integral f dr over some curve path, is independent of path, then f should be equal to grade of phi. So we promise that we will prove the converse. So this is the converse of the above statement, that for a conservative field the work done should be independent of the path. But if the work done is independent of the path, then f should be grad of phi, mean f should be conservative. So if the work done is independent of the path, it is possible only if the field is conservative, or if the field is. If you find the video helpful, like, comments and subscribe.